Welcome everybody from Devnexus. We're here at the DevOps Speakeasy booth. I'm here today with Kevin Dubois. He's going to talk to us a little bit about the session that he has going on.
We're doing a session on serverless Java, but we're going to not just talk about serverless Java. We're going to talk about how can we build serverless Java applications in a cloud agnostic way with as little lock-in as possible.
Awesome.
Which is a fascinating journey.
Yeah. So I remember when the keyword serverless just came out, and everyone was pretty excited about the whole concept and learning functions as a service, things like that. And I think maybe a lot of people are stuck there, right?
Right.
They don't go beyond that.
Yeah. And then there's also that misconception of like, what is serverless? Because yes, of course, there are servers, right? You always have to mention that when you're talking about serverless. But I mean, the idea behind serverless is really cool because you basically only use the resources that you need when you need them, right? There's requests coming in, you scale up to however many instances you need, and then if there's no requests, then you scale down. You're not paying technically anything for the usage of the moments, right? So I mean, the idea behind it is really cool.
That makes sense. So I'm going to age myself a little bit here, but remember when you had to pay for every text that you sent on a cell phone? I feel like we're still in that world when it comes to paying for bandwidth, paying for time in the cloud, that kind of stuff. So this is really important for us to manage our expenses, maybe to be able to predict a little more, and to understand when load gets high, things like that.
Right, yeah. Right, because at some point you have to make sure you have enough resources if you get a lot of traffic in this traditional deployment mode of like non-serverless, and then when there's a lot of traffic, maybe you've still not provisioned enough, and then how do you scale up quickly enough to handle those requests? So the idea behind serverless is pretty cool. Yeah,
still a lot to learn there. And you're going to tell us some tips and tricks how to make this effective for the team today.
Right, yeah. Okay. So we'll talk a little bit about, like functions as a service. So a lot of people think about serverless as, it's Amazon Lambda, right? That's that's serverless. But in reality, it's this concept of, scaling down to zero and up can be extended to a lot more use cases. But we'll first talk about, functions as a service and how it's really cool. You have your Amazon Lambdas and your Azure functions and your Google Cloud functions and your IBM Cloud function, Red Hat. So we're like, we need to also talk a little bit about IBM, I guess. But it's really cool for the providers too, because you get super locked in, especially like, for example, we're talking about Java. And you want to use Amazon Lambda or Azure Functions, you're going to have to import the libraries. You're going to have to write your code specifically tailored for that particular provider. And if you then want to move from one provider to another, it's not just an infrastructure concern of like, well, how do we configure everything? It's like actually rewriting your code.
Right.
Which becomes very expensive very quickly, and so you're very kind of locked into that ecosystem. And then it's not just the code, then you're also using their services, because maybe you need their database or messaging system or something, and and there you go, like, so even more lock-in. So it works really great. It's fairly easy to get started with, but it's also really easy to get locked into those providers.
Yes. So I imagine if you're just starting to do something like this is something that you should consider. As developers, I know, especially I'll speak for myself, I guess. I get super excited with new stuff that comes out, and I just want to get working with it right away. And I can totally see that path of getting more and more locked in. Some of it is a strategy, of course, by the vendors, but some of it is just, unintentional, just maybe not a lack of planning for the future, that type of stuff. Yeah. It is super exciting just to get something working, but then you need to go beyond that.
Yeah, so exactly. Yeah, because you get started with maybe writing a function, and you see like, oh, this is really cheap and it's nice. But eventually, we as software developers, our code becomes more complex, and we want to add more features, and then we go kind of beyond the scope of just a function, right? And then we want to have multiple functions that call each other, and we need, some sort of eventing system in between. And well, of course, the function as a service providers are like, yeah, sure, we have solutions for that too.
Of course.
Like logic apps, and you have eventing systems, and but again, you have more of that lock-in. So we'll talk about, how can we have multiple strategies to try to lock ourselves in less. So one way is, like with the Quarkus framework. There are actually extensions where you can abstract the dependencies out of your code into just a Quarkus extension, and then, in theory at least, you want to go to Amazon Lambda, you use the Amazon Lambda extensions, you want to move to Azure Functions or Google Cloud Functions, you just basically swap the extension, and for the most part at least, your code will be portable. Then there's a specific API in the Quarkus ecosystem that's called Quarkus Funky, which allows you to actually write a function with this func annotation, and all the complexity and the knowledge of how does that translate to the request handler in Amazon Lambda, or whatever other construct of it, is all kind of abstracted away. So you write the same function, and you can deploy it exactly the same way to this provider, to that provider. So
I love that.
That's pretty nice. Now the downside is that all these providers have their own kind of extra sugar on top,
right,
which makes it a little hard for this one Func API to be able to make it exactly portable if you're going to go further than writing, let's say, fairly simple functions. So there's a limitation there.
Yeah.
And so,
That's an interesting topic to explore. I'm head of developer advocacy at JFrog, DevOps company, obviously.
Yeah.
And I've learned a lot about just all of the pieces and parts that you need to put together for a whole, from beginning to end, to get something out in production. And part of that really does involve that interoperability piece, because you want to be able to give people choices. There are reasons they might want to use this particular part for their project rather than from another vendor.
Yeah.
There's always going to be, those complications. And so I like this idea, you want to give people freedom to choose what they need to do, but also that concern for interoperability so that you can pretty much plug and play all of these pieces.
Yeah, exactly. And then you can go further, kind of stepping away from that specific function as a service world into the more container-based serverless world. And so if you start leveraging Kubernetes, then you can use a project like Knative, which is, which enables serverless on Kubernetes, and you can get, basically all your functionality for any code that you write, because as long as you put it in a container, which, basically more or less, any code you can put in a container, you can scale it up and down based on the requests that are coming in. So Kubernetes by default, it can also auto scale, but is based on CPU and memory.
Right.
So Knative actually scales based on the requests that are coming into your pod. So it watches for requests, and that's how it can scale down to 0. And which is something that with traditional auto-scaling Kubernetes you can't do, because it's looking for CPU and memory usage of your pod, so you have to have at least something running to be able to see if it needs to scale, right?
Right.
So Knative is a really cool project because it enables you to use serverless, with Kubernetes, which that makes it a lot more cloud agnostic, because you can basically use Kubernetes either from a cloud provider, or you can, deploy Kubernetes on cloud infrastructure. You can use OpenShift. I'm maybe a little bit biased, but that enables you to go beyond, any kind of cloud provider, or even use serverless on premises, right?
Yeah.
And then, like you're saying, we want to have, interoperability between our different components. So we can standardize how do we send the events, the messages between our different serverless components. And so there's a cloud events project out there,
yes,
which makes that possible, right? Which is trying to standardize, like, how can we send messages from one system to another in a standard way, where it's not, it's AMQP, or it's or this one is JSON, this is Avro, and this uses MQTT protocol or whatever. It's basically, yes, we're just using cloud events, and then we can still define, what the format is of these messages or the protocol, but it's all kind of encapsulated in this cloud events kind of structure. So so that's the idea of like how we can go from very much lock-in to something that's leveraging a lot of open source, open standards. But there's a difference in complexity, of course, so there is a trade-off.
Got to keep the job interesting.
Right, exactly.
Now, I say this year, I said it last year and the year before, this is just a really exciting time to be a developer. All of these tools that are coming in, all of these new ways of thinking about things, new ways to put things together, getting involved. My favorite part of my career is just getting involved with the DevOps team, so learning all of the new deployment tools, getting more excited about that piece of this puzzle that we all work on. Well, I'm excited to learn more. When is your talk?
So it's at 4 p.m. today.
Okay. Yeah. Okay, so 4 p.m. today, learn more about serverless with Kevin Dubois. And it was a pleasure talking with you, Kevin.
Thank you.
And I'll be looking forward to seeing you more at the conference.
Awesome. Thank you.
Thanks, everybody.